Today we are going to be going over actually solving and finding that general or specific solution with differential equations. So for those of you who love a process and who love specific steps, rejoice because there are some very specific steps that AP graders look for when they look at your FRQs on differential equations. So I have them out here on the side and you guys have them in your OneNote if you want to take a look at that. And note that we will get to the second part here, right? So this 4 and 5 we're getting to later. For this top part, we're just going to focus on steps 1 through 3, which are separate, get your x's and y's on the same side, then integrate, and then isolate or solve for y. So separate, integrate, isolate. Let's look at this and try to practice on some of these to see if we can get the hang of it. The very first one says find the general solution for each of the following equations. The general solution, we are not given a point that it's going through. That means we're probably going to have a plus c. So let's get that done here. Our first step is to separate. So we need to get our x and y's on the same side of the equal sign. So to do that, I would multiply by y on this side, and I'd multiply by dx. So I would have, right, so that y cancels. And then we would multiply by that dx to cancel. And what we're left with is we have y dy equals 2x dx. And this is important because what this allows us to do is we can integrate because everything is in terms of the same variable, right? Because we have y, the derivative of y, 2x in terms of x. So this is what we want. Our second step is to integrate. So we're going to integrate here on both sides. And I know the integral of y is y squared. We have that 1/2. And then we have a plus c. Then over here, I'm going to call this c1. I'll talk about that in a second. Over here, this would be that x squared plus c. Technically, this would be like a second c value. What you will notice when you start to solve for y, however, is that I would move these c's and they would end up being on the same side. So really, 1/2 y squared equals, we have x squared. That constant minus another constant is just going to be some constant value. And the reason I show you this is you don't have to show C1 and C2, but I wanted you guys to see that when I am actually integrating both sides, there still is a constant of integration. I just know that it's eventually going to get combined. So if you were to do this, you don't have to name that there's a constant of integration on that side because it will eventually get combined. But that's just good practice to show that it actually does exist. We multiply by 2. Remember that any sort of a constant, this is an ambiguous value, so multiplying it by 2 is not going to it's still going to be c. And then I would take the square root. So this gives us y equals, plus or minus, this is important, we'll talk about that with initial conditions. We multiplied by 2, so that's a 2x squared. And then we still have that plus c. It is also important that you make sure that that c value is underneath that radical, and then we're just going to box in that answer, and there is my general solution. Let's look at b for a hot minute. We know our first step on b is to get x and y's on the same side. So, weird scenario here. I'm going to move this y squared over to the left and this dx over to the right. So I have dy divided by y squared equals dx. My second step would be to integrate both sides. So when I integrate, remember this y squared in the denominator is the same thing as y to the negative 2. So when I integrate that, I get 1 over y. There is a plus c there technically, but when I solve for y, remember that it all gets combined. This equals the integral of 1. That's just going to be an x. We have that plus c. And then I need to solve for y. That is my third step. So that third step, that's solve for y. There is that fun little rule that's saying that if you're solving for a variable or something that's in the denominator, you can essentially switch it on the other side of the equal sign. And that has to do with multiplying both sides by y, then dividing by x plus c. But quick trick, you could just have 1 over x plus c, and that equals y. And that saves you a little time when we have these little tricks up our sleeve. I want for you guys to take a pause and try to do c on your own. We'll do d together, but try to do c on your own. All right, if you guys forgot how to undo a natural log, we raise it to the e. So over here I have those rules, right? I'm raising both sides to e. If you were to leave it here, totally fine. Note that on the AP test or like on a multiple choice, what they might have done is they might have used some of these rules here and said that like, okay, I know if I have 1/2 x squared plus c, that's the same as e to the 1/2 x squared times e to the c. Using those exponent properties, and we just called very similar to that constant of proportionality that we did before. Since we're multiplying, not adding, usually when we add we have a plus c, when we're multiplying we have a k. So this could have been an answer if we were looking at a multiple choice. So just note that like it's totally fine for you to keep it as that plus c, but on a multiple choice they probably would have turned that into a constant of proportionality. All right, let's check out this last guy. This is a very fancy way, like let's be very clear that like y prime is the same thing as dy. So when I am like moving all of this around, like don't be confused by people using different notations. So we have 4y dy, move that, right? So we're going to separate my variables. So we have 3e to the x, this is dx. And then we're just following those steps, right? So we're integrating both sides. Once we integrate, you should have 2y squared. Remember, we do have a plus c, but we're not going to worry about him because we will put him over here with the x's. 3e to the x plus c. And then moving everything around, so we divide by 2. We're solving for y now. We divide by 2. We take the square root. Also, just a reminder that it doesn't matter what c is divided by 2. That is taken into account, and then we're taking the square root. So we have y equals plus or minus the square root of 3/2 e to the x plus c. And we are good to go there. The other way you may have seen this is you may have seen the variables on the same side. So something that you could have seen, especially if you were looking at multiple choices, they won't solve for y. It could have been, you could have had 2y squared minus 3e to the x, and that equals c, right? So just kind of like manipulating those little guys a little bit, moving them around. These are all versions that you may see. I'm going to have you guys pause and try this example 2 on your own, especially if you did not try c or d on your own. Example 2 is a great place to try it out. All right, check out your answer. You should have had y equals the cubed root of 1/3 x cubed plus x plus c. We are now going to move on to like the second piece. Probably what you would see more commonly in an FRQ would be finding a particular solution using an initial condition and separation of variables. Here's where we hit these 2 other steps on my list. Separate, integrate, isolate. Then we're actually going to say let's not leave it as a C. Let's use my initial condition to figure out what C is so that we have that particular solution and it's not as ambiguous. So this very first guy right here, we're following those same initial steps that we did before. So we're separating our variables. Let's get that done. We are going to have, here's t's, here's x's. So we have x dx over here. If we moved this one over, it's important to know that we're dividing by a negative exponent, so he comes up to the numerator to become positive. We're multiplying by dt. So a little tricky math here. Again, remember if we are dividing, we have 1 divided by e to the negative t. We would move him up to make him a positive exponent. So that's where that comes from. Next, I'm going to integrate, and that integral is essentially going to give me that general solution. So when I do that, I have 1/2 x squared equals e to the t plus c. right? I'm going to, this right here, like this is your general solution. I would say pause and like don't try to solve for x, because in this situation, that is not going to be a super easy thing to solve for. Whereas we can pause and like substitute some values to make our lives a little bit easier. So we know, this is kind of like a funky, we're used to seeing that x is that input value. I got by that. That input value is going to be t. And always when they use weird variables, we might say like, okay, this is x of the t. Or my ordered pair, when that t value, right, t value is 1, that x value, t value is 0, that x value is 1. Then I can start substituting in here. So that t value is 0. That x value is 1. Let's get that subbed in. We know that anything to the 0 is 1. And when I get this solved, it is already ready to go and beautiful. I would move that 1 over, right? 1/2 equals 1 plus c. So c equals negative 1/2. Over here on my steps, and I'm going to show you guys like tomorrow in class, we'll look at some FRQ rubrics, and they are almost so aligned to these steps, it's not even funny. So most of the time, these differential equations are something like 5 or 6 points. And essentially, if you follow these steps, and you are good to go. So after I get my c value, I'm going to go ahead and go back and say, let's put that c value back in, because now that I have a value for c, it's going to be a little bit easier to solve for that x. I know that this equation, so this is kind of like a side note in a way. Now that I've solved for that c value, I have 1/2 x squared equals e to the t minus 1/2. Solving, we're going to multiply everything by 2, so I get x squared equals 2e to the t minus 1. And I can leave it there, or I can take the square root, and I get x equals plus or minus the square root of 2et minus 1. Here is where that initial condition comes in. I know that when I substitute 0, I get an output of 1. Which is that like positive value, right? So I'm going to take off that plus or minus, and I'm going to say that like because of my initial condition, therefore we are doing the positive square root of 2et minus 1. And that's using that initial condition to determine what my solution is. So let's look at number 4. And remember, you only have to do that when you're like faced with this whole like there could be a positive or there could be a negative. Then we use this initial condition just to kind of like double check. Let's check out number 4. We are so close. Find the solution of the differential equation that satisfies the given condition. Great. We are back to x and y values. Love that. We are going to say here, let's do our first step. We need to separate our variables. So this guy, we're going to have dy times xy, we'll worry about that x in a second, equals 1 plus x dx. Let's get rid of this x by dividing, so I'm going to have y dy equals 1 plus x divided by x dx. My variables are now separated. That is automatically like 1 point most of the time on that AP test. Then we are integrating. So integrating, and sometimes you get 1 point for each side. Sometimes you just get like 1 point for doing it correctly, but know that this is like a significant step. You have 1/2 y squared equals, it's really, be careful here, because what we have is like, think about this. We have 1 over x plus 1. So this turns into the natural log of x plus c. Now, I do have that initial condition, right? When my x value is 1, my y value, or my output, is negative 4. I'm going to go off and like sub in that initial condition now to find that c, so that I can solve for y in a little bit easier of a way. So we're going to pull off to the side here. not going to use that symbol. We're going to pull off to the side here and say, we know that 1/2 of -4 squared equals the natural log of the absolute value of 1 plus 1 plus c. And when I get that, what is this? 16, 8. Natural log of 1 is 0 plus 1 plus c. So I get that c equals 7. So I would come in here and say, all right, I know that c is 7, so I'm going to continue solving, and I'm going to plug in that c value. I have 1/2 y squared equals, so it's kind of like a side note, natural log of the absolute value of x plus 7. Multiply everything by 2. And then we are taking the square root. Again, we have that plus or minus. Oh, whoops, this was 14. I got a little carried away there. So again, we're taking into account that plus or minus. So I want for you guys to pause and look at that initial condition and see like what that means about the true sign of this solution. We should have noticed that when my input is 1, my output is -4. So because of this value, right, because at x equals 1, y equals -4, we are going to reject that positive solution and say that my particular solution is the negative square root of 2 natural log of x plus 2x plus 14. Because this is a natural log, you may also see that rule where that coefficient becomes the exponent. So this could look like, I just wrote 2 again, the natural log of x squared. And that's kind of nice because that also gets rid of that like need for an absolute value because that x squared takes care of that. But it is up to you here. This is probably the better way of doing so, and that would give you all of your points. I want for you guys to test out this last one, and I will see you guys tomorrow to work on this. Press pause and see this, and then check out my solution. Oh, and just to note, I definitely forgot to add this. I do have domain restrictions here that x and y both can't equal 0 because going back to that original function, right, we can't have that undefined value. So it's just important to note that really quickly. It takes you 2 seconds and keeps you from losing a point. So check this guy out right here. Most of the time I would say that if you look at your particular solution and you have like the same exponent on your x and y, I would probably just set this up to look more like the equation of a circle because of the fact that like it's just going to be so much effort to try to manipulate this, whereas I can leave it like this and 10 out of 10 times, 9 out of 10 times, that is like a good way to leave it. See you guys in class tomorrow. Please look over this work and have any questions prepared and ready to go.